the beginning of time and space? Did everything arise from nothingness, or was it merely a step in a larger cosmic dance? What was there before the Big Bang? This question is one of the deepest mysteries that has gnawed at our minds since humanity came into existence. This question, never ceasing to be asked throughout human history, still hides behind a dark curtain. As far as we know today, our universe began approximately 13.8 billion years ago with that unique moment we call the Big Bang. According to this theory, all space, time, energy, and matter originated from a single point of infinite density, unimaginably hot and dense. With that moment, our universe began to expand at an incredible speed. The temperature dropped, the first particles emerged, and the path to today's dazzling cosmos was opened. But what about before? Was there truly anything beyond that initial moment? Perhaps time and space themselves were born with the Big Bang, and the concept of before becomes meaningless for our laws of physics, much like asking what lies north of the North Pole. Yet, the human mind has never ceased to push this boundary. For centuries, philosophers and scientists have debated whether the Big Bang was truly an absolute beginning, or merely the first page of a larger eternal story. In our journey today, we will explore the most powerful clues modern science offers us about the universe's earliest moments. We will look together at cosmic baby photos, astonishing images revealed by next-generation telescopes, and bold theories pointing beyond the Big Bang. Get ready, because we are embarking on a breathtaking adventure into the universe's deepest secrets. According to the evidence we have, the Big Bang is the time-zero moment of the universe as we know it. In a single instant, all space, time, energy, and matter burst forth from an unimaginable density. In the first fractions of a second, our universe expanded even faster than the speed of light through a process called cosmic inflation. This was the initial critical stage that determined the universe's future. Just 1 second after the Big Bang, the universe was like a hot and dense cosmic soup where subatomic particles churned. Within minutes, the first nucleosynthesis occurred, and the nuclei of the lightest elements like hydrogen and helium formed. However, during this period, atoms could not yet hold together. The universe was so hot that electrons roamed freely, and light particles, photons, constantly collided with them, effectively blurring the entire cosmos like a thick veil of fog. For its first few 100,000 years, the universe seemed veiled in a dim cosmic haze. Light could not penetrate this dense plasma, thus not revealing the depths of the universe to us. Let's fast forward time by approximately 380,000 years. By the time this much time had passed since the Big Bang, the universe had finally cooled enough, electrons bound to atomic nuclei forming neutral atoms. This critical period is called the recombination epoch. And it is a true turning point in the history of the cosmos, because now light was free. Previously, photons that were constantly scattering and trapped began for the first time to travel freely through the void of the universe. The cosmic veil of fog had lifted, and the first light of the universe had spread throughout the entire cosmos. This ancient light, expanding with the universe and stretching its wavelength over billions of years, still surrounds us in today's microwave range. This is called cosmic microwave background radiation, CMBR. This is not a simple glow of radiation. This is the universe's baby picture. Thanks to CMBR, we can see the universe when it was only 380,000 years old. Considering its 13.8 billion-year lifespan, this is almost a newborn baby. This is the oldest light we can observe, a unique memento remaining from the Big Bang's fireball. Accidentally discovered in the 1960s, CMBR was progressively imaged with greater clarity in subsequent years by satellites and telescopes like COBE, WMAP, and Planck. CMBR is not merely a window into the universe's earliest moments, but also the universe's blueprint. Moreover, it harbors startling clues about the universe's composition. Analyses have revealed that ordinary matter, which forms stars and planets, accounts for only 5% of the universe's total. The remaining 27% is dark matter, and 68% consists of mysterious dark energy. This discovery has shown that the vast majority of the universe is composed of unseen and yet to be understood components, and this picture is becoming increasingly clear. In March 2025, the Atacama Cosmology Telescope, together with Princeton University, published the most detailed CMBR images ever obtained. This map was 5 times higher resolution than the full-sky map previously captured by the Planck satellite. The sharpest baby picture of our universe to date had been revealed. After the age of recombination, the universe was plunged into a great silence. As the glow of the cosmic microwave background slowly faded, there were no stars yet. Scientists named this period the Cosmic Dark Ages. There was no light, but there was matter. The cosmos was a vast, dark sea, consisting largely of hydrogen and helium. This silence lasted for approximately 100 to 200 million years. Then, something that changed the fate of the universe occurred. The first stars ignited. These first-generation stars, referred to as population 3 stars, were immense and short-lived giants. As they shone, the dark night was illuminated. This moment is known as the cosmic dawn, the epoch when starlight first began to appear in the universe. These colossal stars, by drawing gas clouds together, initiated the birth of galaxies. Thus, the universe transitioned from darkness to structure and order. Today, thanks to our powerful telescopes, we are beginning to observe this cosmic dawn. The James Webb Space Telescope, launched in 2021, was specifically designed to explore this mysterious era. This is because light from the early universe had redshifted into infrared wavelengths due to the expansion of the universe. Webb's sensitive eyes could capture precisely this infrared light, much like a cosmic time machine. Already in its early years, James Webb shattered records. It discovered galaxies from just a few hundred million years after the Big Bang. The galaxy named MOM Z14, observed in 2025, was one of the most striking of these. Its light had set off only 280 million years after the Big Bang. In other words, this galaxy had existed when the universe was only 2% of its current age. James Webb found a number of early universe galaxies far exceeding expectations. These discoveries astonished scientists because the formation of such bright and large galaxies in such a short time challenged existing theories. The question of how small density fluctuations so rapidly turned into gigantic structures added a new unknown to cosmology. James Webb's findings not only shed light on the universe's early years, but also forced scientists to rethink their own assumptions. As the universe continued to expand, matter, under the influence of gravity, gathered into a giant cosmic web made of filaments and voids. Galaxies were not randomly distributed. They formed an interconnected spiderweb-like structure. The roots of this enormous web stretched back to the tiny fluctuations observed in the cosmic microwave background. One of the cornerstones of modern cosmology is the cosmological principle. This principle states that, on very large scales, the universe is roughly homogeneous, meaning it should look more or less the same everywhere. According to standard theory, the largest structures that could form in the universe should have been approximately 1 billion light-years in size. However, recent discoveries have surpassed this limit. In 2024, astronomers discovered an extraordinary structure they named the Great Ring. This ring-shaped arrangement of galaxies and clusters had a diameter of approximately 1.3 billion light-years. And interestingly, right nearby, another colossal structure called the Giant Arc was found, extending 3.3 billion light-years. Researcher Alexia Lopez, who made these discoveries, stated, "It's not easy to explain these two ultra-large structures with our current understanding of the universe. Their size and shape must certainly be telling us something important. So what do these massive patterns tell us? One possibility is a statistical coincidence. But the discovery of several giant structures in succession weakens this possibility. A more intriguing possibility is that such structures could be a sign of new physics or unknown aspects of the universe's initial conditions. Renowned physicist Sir Roger Penrose argues that these findings might have a much more radical explanation. According to his theory of conformal cyclic cosmology, the Big Bang is not an ultimate beginning. The universe is composed of successive aeons. Each aeon is an age of the universe, and our Big Bang is a transition that occurred after the end of the previous universe. If this is true, structures like the Big Ring and the giant arc could be traces inherited from a previous universe. This idea suggests that the universe is not a one-time birth, but rather is reborn and annihilated in an infinite cycle. The cosmos itself might carry the echoes of past universes. For billions of years after the Big Bang, the universe expanded, but this expansion was slowing down due to the effect of gravity. However, in 1998, astronomers made a shocking discovery. The universe's expansion was actually accelerating. It was as if an invisible force was pushing galaxies apart from each other, propelling the cosmos outwards. Scientists named this mysterious repulsive force dark energy. Today, we know that dark energy makes up approximately 68% of the universe. However, its nature still remains behind a veil of unknown mystery. For decades, the simplest assumption was that it was an unchanging cosmological constant, that is, a constant energy field applying the same force throughout the universe. However, data from recent years is shaking this picture. The Dark Energy Spectroscopic Instrument, DESI, by observing millions of galaxies, mapped out the universe's expansion history. Results published in early 2025 showed that dark energy might be changing over time. Perhaps this mysterious force is gradually weakening. If so, this could completely change the fate of the universe. Today, galaxies are rapidly receding from each other. However, should dark energy lose its influence, this acceleration could one day halt. Gravity might even regain dominance, gradually forcing the universe to contract. This scenario raises the possibility of a future big crunch. This uncertainty surrounding dark energy remains one of the scientific world's greatest mysteries. Whether the universe's acceleration is permanent or temporary will determine cosmology's ultimate fate. If it is a weakening force, cosmic history in the distant future could transform into a cycle, expansion, collapse, and then a new Big Bang. Just as in Penrose's cyclic universe idea in this scenario, the Big Bang might not be a singular beginning, but a recurring cosmic rhythm. Our universe is perhaps merely the latest link in a chain. The other major unseen component of the universe is dark matter. Many observations, ranging from the rotational speeds of all galaxies to their gravitational effects, mandate the existence of this invisible matter. However, despite decades of research, dark matter particles have not been directly detected. This is yet another major mystery in cosmology. The challenge in comprehending dark matter and dark energy has prompted some scientists to develop bolder ideas. Perhaps we do not need these two mysterious components at all. Perhaps we require a new theory, or even a different cosmological model, to explain the universe's structure. One of the most radical ideas that emerged in 2025 challenged the Big Bang theory. Dr. Richard Liu proposed a model of sequential mini-bangs to explain the expansion of the universe. According to him, the universe might have been formed not by a single instantaneous birth, but by multiple bursts of energy and matter that occurred at different times. These mini-bangs could, on the one hand, sow the seeds that trigger galaxy formation, and on the other hand, mimic the repulsive force of dark energy. So, instead of assuming an unseen force to explain the universe's accelerating expansion, it might be possible to account for it with recurring moments of creation. Of course, this is a quite speculative proposal that challenges standard cosmology. However, the history of science has often shown that the wildest ideas are the beginning of great future leaps. Liu's model offers a radical yet intriguing perspective, defining the universe through multiple births instead of a single beginning. These theories remind us that understanding the beginning of the universe is a journey not yet complete. The Big Bang offers a strong framework, but many questions remain unanswered. What if there was another universe before it? Some physicists advocate the idea that there is no before. According to them, time itself was born with the Big Bang. From this perspective, the question of what existed before the Big Bang becomes meaningless. It's like asking what is north of the North Pole, questioning beyond a boundary. But quantum physics challenges these limits. Some models, such as loop quantum cosmology, suggest that the Big Bang was actually a big bounce. According to this idea, a previous universe collapses, then bounces back as our universe. Time continues uninterrupted throughout this collapse and bounce. Thus, there is a before, the universe prior to the bounce. According to this scenario, the cosmos might have an infinite cycle, a continuous rebirth. If this is truly the case, faint traces of previous cycles might be hidden in every corner of our universe. Patterns we cannot discern in the cosmic background or within gigantic structures are perhaps echoes of past universes. Moreover, this idea aligns with findings concerning variable dark energy in recent years. If dark energy weakens over time, the expansion of the universe could one day cease. Subsequently, gravity could become dominant again and begin to contract the universe. This could ultimately lead to a big crunch. This scenario suggests that the universe is not merely an entity born, growing, and ending, but could also be a structure pulsing with an eternal rhythm, constantly regenerating. Today, the evidence at our disposal reveals the universe's past in extraordinary detail. Simultaneously, unknowns, such as colossal cosmic structures, dark energy, and dark matter, continuously render this picture more complex and enigmatic. But what's truly captivating is this: the more we learn, the more questions arise. For now, there are no definitive answers to these questions, but this uncertainty demonstrates the power of human curiosity. Science is not just about finding answers, but also about asking the right questions. And the question of what existed before the Big Bang is perhaps the one that challenges humanity's mental limits the most. Perhaps one day, a new unified theory, a grand framework combining quantum physics and gravity, will explain the conditions that gave birth to our universe. Perhaps future observations will capture the faint traces of a previous cosmic cycle. Or perhaps we will never reach a definitive answer. But one thing is certain: this quest itself is fascinating. Every new discovery about the universe reminds us of both our smallness and the boundless nature of our imagination. And perhaps one of the universe's deepest mysteries is our very capacity for wonder. So, what do you think? What was there before the Big Bang? Share your thoughts with us in the comments. Thank you for accompanying us on this cosmic journey. For more science and secrets of the universe, don't forget to subscribe to our channel and turn on notifications. See you in the next cosmic adventure.